We're rolling.
Okay.
What's it?
Hey, so we're the Astral team from Marquette High School, and this is our quick little introductory video. So our experiment is going to be inside this little chamber, or a better version of it, more realistically. And our primary goal is going to be to study lunar regolith, which is called moon dust in layman terms, and how it interacts with itself, which is cohesion, as well as other spaceless materials called adhesion. And we're basically going to have this little module inside of the chamber, which is blue. And it's going to be sitting right here. And then in flight, this entire thing will be spinning very rapidly. And while it's spinning, the regolith will be spinning around inside of this. When it stops spinning, it will move around inside the chamber relative to the chamber. Now, I wish it was easier to open up this chamber and show you how it works inside. But it's big. If you were to imagine like a dishwasher, or I guess a clothes washer, it has these little plates that are sticking out of it. And it's kind of like whirring around that, and then impacting them and seeing if it sticks or not. So that is the rough overview of how this works. So let's see why this matters.
So the reason why this matters is if we want to do any work on the moon, whether that involves even living on the moon, we got to deal with everything that's there, specifically the lunar regolith. And so the reason why we're doing this experiment is because lunar regolith has some interesting properties, to put it lightly. It also makes building our experiment really hard, but specifically it has some very impressive electrostatic and magnetic forces that it can affect joints and motors, which can make even landing on the moon challenging. So that's why we are going to do this experiment to figure out if there's any materials that can sort of oppose those forces.
Throughout this entire experimental process, there's a lot of things that we need to think about, including construction, sourcing the regolith, and a lot of different other things. Particularly, there's 4 plates inside of here, and each of them are getting their own material that we're going to study. In post-flight analysis, what we're going to do is actually this right here. This top plate will be transparent, and a camera will be mounted on top of it. That's what this black box represents right here. It's kind of like a placeholder. But essentially, what we'll do is we'll take the camera footage and we'll do some analysis of the images that it takes post-flight in order to see how cohesion and adhesion performed in microgravity. In addition, we've had a lot of success and a lot of trouble trying to source all of these materials. So if you need any help with that, we'd be happy to help out. In addition, I want to introduce a smaller secondary payload that we've been working on, which has to deal with a breakout board that has sensors in it. In the top of our experiment, like up here, we will be mounting a couple of amateur space flight sensors and trying to examine how they work. However, we are not exactly experienced in this area.
We don't know how to make breadboards.
Yeah.
Well, we can make breadboards, but not PCBs.
We're learning as we go.
Yeah. So if anyone out there has any suggestions about that, we'd be happy to reach out and see what we can do and see what we can learn. Other than that, I think we've covered most of it.
We're really excited to
Have a place
get to know each other and just get to chill with all the other great teams. So,
and if you want like a more in-depth video of exactly what we're doing because you want to help out or just learn a little bit more about us, you can find that on our YouTube channel. Just look up us, Astral Orbit.
Or in the Shameless Plugs channel.
Yeah. All right.
That's a plug. Yeah.
Rusty, do you want to?
There's a Rusty.
Do you wanna give
Rusty
the outro?
cameo.
Give the outro.
What?
Say subscribe.
Oh, subscribe to. This is probably not going up on Astral.
No.
Subscribe to Lars to T-Bro. Don't ask why it's called Lars to T-Bro.
All right. I think that's good.
I'm still disappointed with myself.